Okay, guys, I'm going to start with the verse of the day because this is a typical way I start my classes. Okay, we do a verse of the day. We spend a few minutes looking at a Bible verse and then pray. And when I look at the Bible verse, it's always got some blanks in there. Some of you may already know this verse, and some of you may not. To the extent that you can, I want you to try to cooperate with me and say the words if you can. Now, what happens to a lot of classes is the shy kids will just, I'm gonna guess, and then some that are more courageous will guess at the words. And I like it when you guess. If you don't know, sometimes we'll have a kind of an interesting time with people guessing the words. But don't just rely on one student to get it right every time. I'm not going to call on you and embarrass you or anything. I just want you to participate in it if you possibly can. And this verse says, if you something with your something, that's, I bet you know what that J word is because it's capital J, is, I bet you know what that L word is because it's capital L, and something in your something that God, something him from the something, you will be something. So we got to figure out what that verse is. Does it ring a bell with anybody yet? Anybody think you know what it is? Think you know what it is? Okay, awesome. I'll tell you what I'm going to have to do is keep my list up here. There's no way I can get your names right yet. So, okay. I may make a seating chart to help me out. If y'all sit in the same seats, are you comfortable where you are right now, everybody? If you'll sit there every time, it'll make it a little easier for you. Okay. All right. What do you think? If you what? You don't have to raise your hands. Just call it out. Comes a good guess. Comes a good guess. Confess. Confess. Yes, confess is the word. See, thank you, girls, for guessing those. Those are good guesses. I might have guessed it myself, except I know the verse, So it's good guesses. Don't worry about making bad guesses. Don't feel embarrassed about it. If you confess with your mouth, with your mouth, that Jesus is Lord, and believe in your heart that God raised him from the dead, you will be saved. Very good. That's it. Romans 10:9. That's an awesome verse. And I put it up there first because it's a great verse to share with somebody if they want to know how to become a Christian. That's all right there. One of the most important things to learn about becoming a Christian is it is not complicated. Even little children. In fact, Jesus said you have to come like a child. If you're going to come to me, you got to come like a kid. And now it has to be real. And so a lot of people will say the words, but it's not their heart, So you got to be real about it. It's got to be sincere. But that's why I said be like a little kid. It has to be genuine. So confessing with your mouth means I'm saying with my mouth, Jesus is Lord. Jesus Christ is Lord. He's God. He came and died for my sins. He rose from the grave. He's ascended to heaven, but he's my Lord. He's my boss. He's in charge of me. That's who I am. Jesus is my Lord. And I believe in my heart that God raised him from the dead. I know he didn't stay dead. I know he died on the cross. I know they buried him, and he didn't stay dead. One of these days, you'll take a course here, I hope, and I hope I'm still here to teach it, called Warriors of Christ. And we spend a lot of time talking about the evidence that God's given us for these things so that nobody will be able to confuse you later on and say, well, that didn't really happen. No, yes, it did. God's given us lots of evidence. Jesus is risen from the dead, and we believe it. We'll be saved. So we don't have to worry about whether we're saved or not. He says, you will be. You accepted Jesus as Lord. You believe God raised from the dead. You're saved. So it's just that simple. Of course, it's complicated, but it has to be real. So we're living our lives for him because he's the Lord. Now, the next thing I like for us to do is spend just a little time seeing if we can get it memorized. Some of you may have already memorized it, but we'll just kind of go over it. And I know you can't really memorize a verse well in just a very few minutes that we have, but maybe it'll help it stick a little bit. So let's see if we can do this. If you confess with your mouth, if you confess with your mouth, if you confess with your mouth, if you confess with your mouth that Jesus is Lord, that Jesus is Lord, that Jesus is Lord, that Jesus is Lord. If you confess with your mouth that Jesus is Lord and believe in your heart, believe in your heart, and believe in your heart, and believe in your heart that God raised him from the dead, 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 you will be saved. You will be saved. You will be saved. So there it is. And let's see how much of it we can get. I'll help you if you get confused, but how does it start? If you confess with your mouth that Jesus is Lord, if you confess with your mouth that Jesus is Lord, and believe in your heart What? That God raised him from the dead, you will be saved. That's it. You just already memorized. Good job. Okay. Now the next thing I always do after we talk about the verse like that is spend a little bit of time. I'm going to pray. If you have a prayer request, or if you have something you want to say about the verse or something else that's on your heart, this is the time to do it. We can't have a long discussion because we got math to do, but we'll have some. You see what I'm saying? So I'm about to pray unless you have something you want to say before I pray. Everybody good? Okay. Well, Father, thank you so much for these kids. They're a blessing to me. It encourages me for them just to be in my class, Lord. So I thank you for them, and I pray your blessings on them. And Lord, the expressions on their faces encourage me. And I believe that these kids are probably kids that love you. And I pray you'd bless them. Thank you so much for giving us this verse that you caused Paul to write to the Romans, that if we would just confess with our mouths that Jesus is Lord, and Lord, that's what we're doing. We're saying we know that Jesus Christ is Lord of our lives, and he is God, and that you raised him from the dead. We know that's true. We believe that in our hearts for certain. Then we know that we belong to you. We're your kids. We've been saved because of Jesus and what he did for us on the cross. So thank you, Father, for this wonderful truth in this powerful passage of Scripture. And help us to look for opportunities to share that with other people as time goes on, that we can tell them this truth from Romans chapter 10. So thank you for this verse. And Lord, thank you for these kids. And I pray that you'd help them to be encouraged and to be excited about this year. And I pray you'd help them to know they're going to learn math. And if they're put forth the best effort, then help them to know I'm going to encourage them and help them the best I can to do a good job. And I pray you just bless them and help them to keep a good spirit and a good attitude. Help us all to do that. We just want to make you happy. We want to bless you especially. So help us to bring you lots of glory and help these kids to feel comfortable to ask questions if they wonder about something. And we just want to learn what you want us to learn today. In Jesus' name, amen. All right. Now, if you get a question in your mind, feel free to ask me. I'm not going to go over all of this letter, but that letter that I gave you, I want to show a couple of things real quickly. Starting on bottom page 3, which says class rules. See it? See it? I don't think I'll have any problem with any of you at all. I just really don't. But I feel like I need to go over this real quickly. Number 1, respect and be polite to all people. That obviously goes without saying, and I think all of you will be very respectful. That's especially to Jesus and to God. I have had students, even in this school, bless you, I've had students even in this school, but especially when I used to teach at Tellico Plains High School, I have students who will use God's name in vain. The way they do it is, you hear it on TV all the time. And a lot of people do this in their homes, and that's none of my business ultimately. I mean, that's their home. But I told the kids in Tellico, I know this is a public school, but this is my classroom, and I'm a Christian, and I don't want you using God's name carelessly in here. So what they would do is they'd forget and they'd get upset and they'd get angry or get upset or get surprised. They'd say, "Oh my," and they'd throw God's name out there. And I know a lot of people do that. You hear it on TV all the time. And when I'd catch them, I'd say, no. I'm Mr. Hall. I'm not God. No, I wouldn't call it. And then say, "Oh, I saw it. No, I didn't mean anything, Mr. Hall." And I would say, that's the problem. When you use God's name, you need to mean something. You need to be talking seriously about Him or talking to Him. Now, I know this is a public school, but in my classroom, if you want to talk to God, that's fine. I'll be happy for you to talk to God. But don't just use His name like some careless word. So don't do that. So obviously that's important. And none of you are going to be rude or disrespectful. I'm totally convinced. Number 2, on the next page, respect the property of others. One of the problems with little tiny classrooms like we have here, especially if there are many kids, is you'll have trash and you think, well, I can't get up. It's too easy, too hard to get up. I'll just put it on the floor and I'll get it later. The problem is you tend to forget. Some students do anyway. And so I'll wind up having to pick up trash off the floor. So I would rather you just, if you've got trash of any kind, paper you want to wad up or you've torn off some little pieces of paper for some reason, either hand it to me or hand it to a student and pass it down and get it to the trash can. Just don't lay it in the floor. Thank you. Good job. And and I don't mind you getting up, if you can get up, but it's just sometimes for you that they're kind of on the inside, it's kind of a little room. All right. Bring all materials to class every day. The truth is, you don't have to bring this book every day. It's a big old heavy book, isn't it? So you don't have to carry it around. If you want to leave it at home, that would bother me. Because the stuff that I want you to see in this book, I'm going to put it on the screen. And then when you get home, you can see it and study it. And By the way, I try to make a video of every class, and when I do, post it on YouTube, and I'll show you the link to that and everything. So if you want to rewatch something, you can, or if you miss a day, you can see what you missed and that kind of thing. So I'll try to have it all there for you. But I've got slides of the pages in this book that you, if you need to see them, I'll put it up there. So you do not have to have that book. I will also say this while I'm thinking about it, and I'll probably think of other things as I go along. The assignments will be out of that book. The assignments they're out of that book. Most of the students just do the assignments right there on the page and just turn it in. But some students like to do it on a separate sheet of paper so they can keep those pages in the book. That works great for me. I like either way, I'll accept it. The only thing I require you to do as far as your assignments are concerned is get your parents to look at it and say, yes, they believe you did this right. It's not just that they know it's yours, but they're saying, I looked over it and I believe they're doing it right. I understand. Yeah, that's true for a lot of moms, by the way. And she doesn't have to understand all this, although she might learn some of it with you, as you go on. Because this is a blend, it's homeschool and Christian school kind of at the same time. That's where you're going to meet every day. I've only got 2 days with you, and about an hour each day. So I've got to cram a lot of stuff in real quickly, and I'll depend on your parents to kind of help you figure it out at home. You're going to have my phone number, so if you can text me if you got a question. I'll be glad to answer questions if you text me during the week. So anyway, uh, but they don't have to verify that every single problem is correct. They just want that you did your best and you tried to. In other words, I've had kids go down there just barking crazy answers down. They didn't bother doing it. They just turned. And if the parents say it's okay, I'm gonna say okay, but parents be aware what your kids are doing. They think about it. So just get your parents to sign at the top or whatever that they checked over your work. Uh, you understand what I'm saying? It doesn't have to be perfect. I'm gonna give you credit for assignments when you turn them in. All right. So you don't have to have that, but you do need to have pencil and paper. If you don't have a pencil and paper, if you lost it, usually I've got some up here extra that you can have. So I don't mind you taking it, but I'd obviously rather you bring your own. And then assignments to turn in. I'll talk more about assignments in just a minute. Um, I would like for you to use the restroom before you come to class. Now, I realize some of you may have forgotten to do that. And you may be, oh, I got to go, I got to go, I got to go. Okay, well, just tell me and I'll let you go. I will. I will let you go to the restroom. But I'd like for it not to be a bad habit. I'd like for you to be in here the whole period. And if you need to go, I'll let you go. But try to make sure you use the bathroom before you come to class. Uh, Self-control, number 5. I don't know if talk about that. You're not going to have a problem there. And all school-wide rules, the dress code, whatever Miss Melissa says the dress code is, we've got to abide by it. Okay. Cell phone policy, same thing. By the way, what I will ask you to do any of you have cell phones? Okay, if you do, if you would, when you come in, just put them in here. We're trying to do that for everybody. You don't have to right now, but next time, and you can see it that way. And when you leave, you can grab your phone and take off. But we're trying to do that because we've had a problem in the past with kids sneaking their cell phones out and having them in their lap or having that thing in their ear, they can hear, and it's distracting, of course, from what they're supposed to be learning. Yes, ma'am. You don't have to. That's a good question. Yeah, yeah. I don't think, unless it's a problem, just your phone. That's all I'm answering. I think. Usually have much of a problem, I don't think, but I wouldn't be surprised if some kids have snuck some things out. But for the most part, I won't say that. But anyway, I think it's going to be fun. All right. Any other questions right now before I go? I don't think there's going to be any problems at all. Now, guys, let me tell you something. I'll give you assignments every day. There'll be sometimes I will cover 2 or 3 sections in a day or more, depending on. Sometimes you'll be already familiar with it, and you'll have assignments over that. My goal is to quickly cover those things so that we can get ready for a test. Before the test, I will give you a handout, and the handout will be copies from the slides that I do, and it'll have problems on there that if you know how to do them, you'll be good to go for the test. It won't be the same problems on the test, but it'll be problems like the problems on the test, same kind of problems. Okay, so if you understand how to do those problems, you'll be good to go for the test. And I'll spend time going over those things in class. So you can say, Mr. Hall, wait a minute, I don't get it. Would you do that again? Yes, I will. I'll do it again as much as we can. So uh, that'll get you ready for the test. Now, If you're overwhelmed with assignments, let's say you got a bunch of teachers giving you a bunch of stuff to do, and you got something going on at the church, and you got something, and your family's doing something, or somebody's sick, or you got to make a trip, and you think, how am I going to get this done? Well, listen, you can turn my assignments in late, and I'll still take credit. I'll still give you credit for it. I would really encourage you to get them in before the test, because that's going to help you get ready for the test. Most of your grade is going to come from the test. Some of your grade comes from the assignment, but the biggest part of your grade comes from test. Got another question? Okay. So so I would urge you to get those assignments in as timely as in a timely fashion, as quick as you can. Get them done. But if something happens and you can't get it done, don't panic. You'll be good. Just turn it in. It'd be better to turn it in for the test if possible. If you miss a test or if you bomb a test, I'll let you take it again. I will. We'll just work out a time for you to take it, retake it. So that gives you an opportunity. That'll help you relax a little bit too. If you think I'm a bad test taker, Mr. Hall, because I stress out, well, relax the best you can. Take a deep breath and just study hard so you know the stuff, and then do the best you can on the test. And then if you happen to do poorly, you say, well, I can retake it, so I don't have to stress. I'll do the best I can. So don't stress. Uh, all right. Uh, if you don't know your multiplication tables, shame on you. Learn them. Get you a deck of cards or something. It's going to make a huge difference, because I will not let you use a calculator in here on your test. Now at home, if you have a calculator and you want to do your problems the old-fashioned way without a calculator, and then use a calculator to check it, that's fine with me. I don't care. See if you're doing it right. That's a good way to check it. But I'm not going to let you do that on the test. On the test, you got to do the best you can without a calculator. Okay, got it? All right. Is there any question you have right now about what I'm doing? Anything else? If you think of something, let me know. Okay. All right. So the next thing I'm going to do is, let's see. Hold on. Let's try this. Find this. Now you're welcome to thumb through your books, but if you want to mark things and that kind of stuff, that's fine. But you don't have to. You can just watch me here and kind of stay with me the best you can, and then you'll see this kind of stuff in your book. I can't tell you exactly where it is in your book, but this is in our good book. So let's kind of get started here. Unless you have a question, I'm on along. Okay, everybody good? Everybody with me? All right, let's go. Uh, these numbers are called counting numbers or natural numbers. They start with one, not zero. Have y'all studied sets of numbers before? The counting numbers start with one, one, two, three, four, five, and those three dots mean one. They just keep going. Yep, they keep going. One, two, three, four, five, six, seven, on and on, infinitely. Never stops. Those are called the counting numbers or the natural numbers. If you put a zero in there, they're now called a different set. They're called the whole numbers. So when we talk about whole numbers, we're talking about the same natural numbers, except we're including the zero. Okay? Well, these do not include fractions, decimals. These are whole numbers, natural numbers, counting numbers. Operations of arithmetic, addition, subtraction, multiplication, division. You're familiar with all of that. We'll be doing that sort of stuff. Of course, you've done that for years. Money is sometimes used dollar sign to indicate it, like 50 cents, or sometimes with a cent sign, 50 cents. If you see this, most of the time we're going to change it to this. When we work with dollar questions or money problems, almost always, we're going to change it to a decimal dollar. 1.50 is 50 cents, half a dollar. So be prepared for that. Sometimes you'll see something misplaced. Soft drinks. What does that mean? Look at it carefully. What's it mean? The way they've written it there. Yeah. How much would you have to pay for a soft drink here? What? Look at the way they've written it. No, have you figured it out? Yeah. What does this mean? The way they've written it? What does it really mean? They don't mean it this way, but what does it mean? Yeah, like half a cent, 0.5 cents is the way they've written it. You'd get two for a penny if the way they've written it here. They chose, this is the dot with it. If they put a dollar sign out front, that would make sense, 50 cents. But they use a cent sign with a decimal, that makes a penny. You see what I'm saying? So you got to kind of think about which way it's being written. If they give you something with a cent sign, you might want to change it to dollar, but that doesn't look logical. That looks like an error, and it is. Okay. A lot of times we're going to be using letters instead of numbers, and they're called variables. You've probably worked with a few variables before too, maybe. And when you try to figure out what the variable equals, we call that evaluating the expression. We're evaluating an expression when we find out what the variable is. We'll ask you sometimes to evaluate this expression when x is 5, and then I give you an expression with an x in it, and you have to evaluate it. We'll learn how to do that. Evaluate. All right. Um, so we already talked about this. What are two ways to correct this? Okay. You could just say that's 45 cents. Yep. What's another way to correct it? Put a dollar sign out front. Leave off the cent sign. So either one of these makes sense. That's 45 cents. That means 45 hundredths of a cent, which is less than half a cent. Okay. Name a whole number that's not a counting number. Name a whole number that is not a counting number. Nope, that's a counting number. Zero. Zero is the only one. The only whole number that's not a counting number is zero. Yep. The other counting numbers are all whole numbers. Look at this one. When the product of four, you know what product means? You know what product means? Always means multiplication. Always means, when you see the word product, it always means multiply. Always. When you hear the word sum, what does it mean? Addition. It always means addition. Always means addition. When you hear the word difference, what's it mean? Subtraction. When you hear the word quotient, what's it mean? Dividing. That's right. So when you see the word product, it always means multiply. When the product of 4 and 4, that means 4 times 4. Are you familiar with raised dots for multiplication? Have you seen that before? You know, you can show multiplication several ways. 4 times 4, raised dot. 4, for instance. Have you seen it written like that? It means multiply. Sometimes you'll see it written like this, and we'll occasionally use it that way. But you'll see those little X marks less and less because they look too much like variables. So we don't use that as much. We use these more often. And of course, if you see a variable written by a number, that means multiply also. 4 times y. Okay? All right? So when the product of 4 times 4, that's 4 times 4, is divided by the sum of 4 and 4, you could write it like this, is divided by the sum of 4 and 4, that's when you add 4 and 4. What's the quotient? Very good. 4 times 4 is what? 16, and divided by 4 plus 4 is 8, so the answer is, yeah. And you realize you can write division like this, divided by, or like this, divided by 16 divided by 8. 16 divided by 8. All right. So good? Okay. Sorry, say it again. Mm-hmm. For instance, you're getting into order of operations. We'll talk more about that later, but you always do multiplication and division before you do addition and subtraction. That's what you're asking. Yeah. Is that what you're talking about? Yeah. Okay. Now, this one says add, subtract, multiply, or divide as indicated. This means we're what? Adding. What are we doing here? Multiplying. Multiplying. Uh-huh. Dividing. Dividing. So pretty clear there. Everybody knows what we're doing. And here, you know what I'm going to do first here? You want to guess what I'm going to do? Yeah, I'm going to change this to the, like I said a while ago, I'm going to change this to this. and make it dollars. I'm not going to put the dollar sign in usually, but it's 65 cents still, but it's decimal dollars. Normally we don't use that. You can, but you're going to get a bunch of pennies there. Let me show you what I mean. If I left it like it is and multiplied it by 5 times 5 is 25, it's 32. No decimal. That's my answer. But it's 325 cents. We don't usually talk like that. We don't say 325 cents, we say $3.25, right? So when you change it to a decimal, you'll get this when you multiply it out, $3.25. I'll do the same thing over here. $2 minus 47 cents. Change that cents to a decimal dollar. And when you subtract, you're going to have to borrow here, right? Remember how to do this? It's like 200 is the same as 190, 10. 10 minus 7 is 3. 9 minus 4 is 5. 1 minus 0 is 1. $1.53. On a test, how could you check to make sure that was right since I won't use use a calculator? Yeah, you could add these two numbers together and see if you get $2. And you will. Because it's easy to make a little careless mistake up there when you do a fraction. A lot of students don't like math. And a lot of students say, why do we have to learn this stuff? Parents tell me I'm never going to use it. Well, be careful. You might be surprised at how much you use in life. It depends on the job you wind up in. I remember my wife, when she went to school, she was good at math, but of course I didn't know her in those days. But she thought, I'm never going to use this. She was in algebra. She said, I'm never going to use this algebra. And the first job she got out of high school was working for an insurance company. And she was shocked at how much algebra they had to do. She said, we did algebra all the time, and the formulas are the insurance formulas. So, yeah, yes, ma'am. A dentist? Yeah, dentist will need some math. You got to pay attention to your math. Yes, that's right. There are just lots of things in life in general that it's good to know math for. It's handy. Oh no, if you're going to figure out a tip at the restaurant when you buy a meal out, and you'd be able to do some math. And I know you could grab a calculator, but it's nice if you can just do it. And let me tell you something. When I taught at Teleco, I probably ought to put it up here too. I had a big sign up at the top of the screen that said "Math: Calisthenics for the brain." You know what calisthenics are? It's like a form of exercise. Calisthenics. So I said, math exercises your brain. It makes you learn how to think. It makes you learn how to memorize and think about things. It makes your brain more adaptable to work in life in general. You need a working brain, and math will help you make your brain work. It forces you to think logically and systematically. It's just a good exercise. So you need more than you think. I had another student one time. It's a little more advanced than you are, but we were studying a little bit of trigonometry. And trigonometry, it's kind of get some of that in algebra 2 and geometry, but then it's trigonometry course after that. And I had one of my students came in one day and said, Mr. Hall, I didn't think I'd ever use this trigonometry. But he said, my dad's a roofer, and he asked me to come help him. And he said, we were using trigonometry to solve the problem about the roof we were working on. Oh, okay, cool. It just shows up more often than you think. I'm trying to ask something else. What? Oh, yeah. Yeah. There you go. What, is he still teaching? Where did he teach? Washington State or Washington, D.C.? Wow, wow. Yeah, I know it's true. Teach a Sunday school class out at Fairview. You need to go to Fairview Baptist Tabernacle. You may go to Fairview. Anyway, I teach a Sunday school class out there, and it's amazing how many people have come into our church and in our class from California and Washington and different places. There you go. We're in Texas. Readable. Yeah, I know we're good. My wife was raised there in the Dallas. We lived in Dallas. I lived up there for many, many years, and she was lived all her life there. We moved up here in 1999. Uh huh. Yeah. Yeah, she was raised in Rockwall. We lived in Garland, because Garland. Rockwall. Yeah. Anyway, a lot of people come from other states of Tennessee. Now, Texas is a lot like Tennessee in a lot of ways. I used to tell them in Texas, all the great Texans came from Tennessee, like Davy Crockett. And yeah, 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 yeah. All right. So I'm assuming you guys can handle this. Let's look at this last one here. Evaluate expressions for A equals 20 and B equals 4. Now look, you got to understand what they're saying here. They're telling you up front, A is 20. Every time you see an A, what are you going to do? Put a 20 there. Substitute the 20. It's called substitution. Substitute the 20 for the A. And every time you see a B, put a 4 there. So A plus B is 20 plus 4, which is 24. A minus B is 20 minus 4, which is 16. What's that mean? What's that mean? Yeah, A times B. AB is 20 times 4. Now, you can't just write 20 beside a 4 like that because that's 204. So when you see the letters written beside each other, you know it means multiply, but you got to use a multiplication symbol when you change it to numbers, either parenthesis or a raised dot, which of course is 80. And finally, 20 divided by 4 is what? Thank you. Okay, let's divide. All right. So uh, most of this you've probably done before. And guys, listen, know I go quickly in class. And like I said, you can watch the video later if you get a little confused. But it's all right for you to stop me and say, "Would you do that one more time? I didn't quite get that," or I'll be glad to. But just that's fun. But unlike you, when you're sitting there in the class just trying to pay attention, and I'm up here talking, your brain suddenly goes somewhere over here, and all of a sudden you come back. Whoa! What did he just do? Well, just say, "Mr. I'm sorry. Would you do that one more time?" And I will. I'm going to set you. Okay. Um, now let's see. By the way, your assignments, this is one of your assignment pages. I'm not going to go over these now, but I'll do some of these when we do it and for the test, which I'll probably give you next time. But most of the time, in fact, all the time, I'll just ask you the odd ones just to make it a little easier for you. You may want to do some of the even ones to make sure you know what you're doing, but I'm not going to require that. I just want to make sure you're doing enough that you understand what you're doing. All right. Inverse operations is what we're talking about here. And these are operations that undo each other, addition and subtraction. If you add a 3 to a 2, you get a 5. If you subtract that 3 from the 5, you get a 2. So they're inverse operations. So if you add a 3 to the 2 and then subtract the 3 from the 2, what you wind up with a 2 because these things undo each other. Make sense? Yeah. Yeah. That's what you need to learn about that. Equals 2. Mm-hmm. Okay. This is the commutative property. There's a commutative property for addition and for multiplication. Have you heard of the commutative property before? Is that new? Is that new to you? New? Okay. Commutative. You know what? You know what it means to commute from where you live to somewhere else. Like some people commute to go to work. They live in one town, they work in another town, or they commute to go to school. They live in one town, they go to another school in another town. It's called commuting, and it means they go back and forth. They go to that town, they come back over to this town. Well, commuting means if I add 2 plus 3, it's the same thing as the other way, 3 plus 2. It's called the commutative property. It works for multiplication too. 2 times 3 is the same thing as 3 times 2. That's the commutative property. So if you use only letters, A plus B equals B plus A. It doesn't matter which order you put them in. It doesn't matter the order. It doesn't matter the order. That's not true for subtraction, you realize, or division. If I divide 24 by 12, I know that's 2. But if I divide 12 by 24, that's a half. So 2. So division's not commutative. Subtraction, if I subtract 8 minus 3, I get 5. Yes. Good morning. Okay.
I'll be back in 20 minutes.
Okay. Are you Miss Hall?
I'm Miss Hall.
Does Miss Hall work at the other building?
Martha?
Yeah, I don't know.
She's in here. Yes, she teaches English.
No, I mean that's Howell. No, there's a new person called a coach, a character coach or something like that.
Oh, Deborah.
Yeah.
Yes. So she's in and out.
She should be in both buildings. Okay.
I have schedule.
Okay.
I took a picture of it. So, you can email it.
Yeah, that's fine. Here, let me give you that part. You can just text it to me. Does that work?
Yes.
And what's your name again?
Andrea.
Andrea.
Andrea
Okay.
Carl.
Well, this is the wrong part. This is the Sunday school part. That's all right. My name's right there. My number's right there. Thank you, Andrea.
Thank you.
Uh, so what did I do? I'm saying subtraction is not commutative. 8 minus 3 is 5. But 3 minus 8 is not 5. That turns out to be a negative number. We'll talk about those later on. You see what I'm saying? You can't say 3 minus 8 is 5. That's just not true. This is true. So subtraction and division are not commutative. Addition and multiplication are commutative. Got it? Okay. The identity property of addition, identity property, says that when you add 0 to anything, you get what you started. You knew. That's just kind of common sense. So sometimes they call 0 the additive identity. Multiplication and division are also inverse operations. They undo each other. If you multiply 4 times 5, you get 20. If you divide 20 by 5, you get 4. So if I multiply 4 times 5, and then whatever I get, I divide by 5, what am I going to get? 4. 20 divided by 5 is 4. They undo each other. Multiplying by 5 and then dividing by 5 undo each other. Same thing if I said 4 divided by 5, and then whatever I get, I'm going to multiply by 5. You know what that's going to equal? 4 again. Because dividing by 5 and then multiplying by 5, they cancel each other out. They undo each other. You see what I'm saying? They're called inverse operations. If you multiply by 5 and then divide by 5, they cancel out. If you divide by 5 and then multiply by 5, they cancel out. Make sense? They undo each other. Inverse operations. Just like adding and subtracting. So now we're multiplying and dividing. Don't worry too much about all that. Let's see. The commutative already. Identity property for multiplication is a 1, a times 1. Any number times 1 gives that number itself. A while ago I said any number plus 0 equals that number. Any number times 1 equals that number. So that's called the identity property for multiplication. I had a math teacher years ago who tried to make this point so strongly. He would almost never call this a 1. He would call it the identity. He said, we're going to multiply by the identity. Okay, that's 1. But he just tried to drive that point home. It's called the identity element for multiplication. So when you multiply a number by 1, you get what you started with. If you multiply a number by 0, you always get 0. So 5,265 times 0 is 0. Easy, right? Anything multiplied by 0 is 0. Really? By the way, every now and then you see these little things that I've circled, and you don't have to worry about it. That was mainly for my sake, because I went through and did this on my screen when I realized there was going to be a problem like this on the second test. Actually, this isn't even on the first test. On the second test, they're going to have a problem kind of like that. So you'll need to be aware of it. When you see that, it's a kind of a heads up that they'll do a test question like that sooner or later. This is the associative property. You need to be familiar with these properties. The associative property. You remember the commutative property said you could switch the order, right? You could switch them back and forth. The associative property doesn't change the order. A, B, C, A, B, C. You see it? The order didn't change. A, B, C, A, B, C. What changed is the grouping. You see it? So we group the A and B together here. We group the B and C together here. And the associative property said it doesn't matter. It doesn't matter. So if I've got 3 plus 5 plus 7, normally this tells me I'm going to add this first, right? For instance, tells me to do what's in there first. 3 plus 5 is 8. So I've got 8 plus 7, which is 15. Come in. Got it? Okay. This has got to do with grouping, though, not order. Grouping 3, 5, 7. I'm going to write it again. I'm going to leave the order the same. I'm not going to change the order like I would in the community property. I'm going to leave the order the same. And now it's 3 plus 5 plus 7. Now guess what I'm going to group together? Yeah, the 5 and the 7. Up here I group the 3 and the 5 together. Down here I'm grouping the 7 together. Does it matter? No, it doesn't matter. Mm-hmm.
Still,
Mm-hmm.
you know what?
Mm-hmm. Oh yeah. Mm-hmm. 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 You can see it. Yep. And I've told them already, I'm making a video of this right now. So when they will go home, if they want to watch that video, they can watch it on video and say, oh, yeah, I remember now. I didn't do that. So they can, yep, same thing. Yep, yep, yep. Note takers are wise. But you see it, don't you? The order's the same 357, 357, but the grouping's changed. But look, 5 plus 7 is 12, and 3 plus 12 is 15. I get the same answer. Didn't matter. Didn't matter. So the associative property, and by the way, the word associative comes from the idea of associate. You know, you associate with people, that means they're the people you hang out with. You associate with them. So these two are associated together, and these two are associated together. So we call that the associative property. It's got to do with grouping. The order stays the same. And there's one just like it for multiplication. If I multiply 3 times 5 times 4, it's the same as multiplying 3 times 5 times 4. See, it sounded the same because the order's the same. The grouping's different. 3 times 5 is 15. 15 times 4 is 60. 5 times 4 is 20. 3 times 20 is 60. It doesn't matter. You get the same answer. The order doesn't change. The grouping's what changed, and that's called the associative property for multiplication. You okay with that? Very good? Okay. Some more for subtraction or division, just like the community property. You can't do it with subtraction and division. Only multiplication and addition. Sequence is an ordered list of terms. This is the set of whole numbers, 0, 1, 2, 3, 4, but they're in sequence. You could have the even whole numbers, which is 0, 2, 4, 6, 8. All of them are divisible by 2 without a remainder. You could have the odd numbers, which is adding 2 to each one, but you start with an odd number. 1 plus 2 is 3. 3 plus 2 is 5. 5 plus 2 is 7. 7 plus 2 is 9. You can have patterns like that of numbers that are sequences. I could start with 3, 1, and add 3 to each one. 3 plus 1 is 4. 3 plus 4 is 7. 3 plus 7 is 10. 3 plus 10 is 13. You see the pattern? You can have all kinds of different patterns like that, and they're called sequences. The most common one are consecutive numbers. We call them consecutive when it's just, you don't skip one. 1, 2, 3, 4, 5. You can start with 20, 21, 22, 48, 49, 50. Those consecutive numbers. Or the odds, or the evens. This is even. 2, 4, 6, 8. Again, you can start anywhere. You can start at 86, 88, 90. You can start 85, 87, 9. Yeah. But you see a pattern. Watch for the pattern. Which number is known as the additive identity? You know what the additive identity is? 0. When you add 0 to any number, you get the number you started with. Which number is the multiplicative identity? No. Multiplicative identity. 1. When you multiply anything by 1, you get what you started with. 45 times 1 is 45. So this is 1, this is 0. Which operation is the inverse of multiplication? Which operation undoes multiplication? Division. Division and multiplication undo each other. Got it? Use the letters x, y, and z to write an equation that illustrates the associative property of addition. So, x plus y plus z. I'm going to start that for you. It's the same as what? You know what I'm going to write for this, make this associative? I'm going to put these two together. X plus y plus z. The order doesn't change in the associative. Order doesn't change. Same order, x, y, z, but the grouping did change. So these two, I'm grouping these two. Then write an example using counting numbers of your choosing. So I could have 5 plus 7 plus 2, or I could write parenthesis 5 plus 7, put them together. Does that make sense? You know what I'm saying? Okay. Name the property we can use to find the missing number in this equation. This is 5 times something equals 8 times 5. Guess what that is? 8. Property tells me that that's true. You remember? No, it's a property. There's the identity property. There's the community property. There's the associate property. Which one is this? This is the one that says I can switch the order. Community property. The community property. This is 5 times 8 equals 8 times 5, and that's the community property. COMM period. But you can figure out community for me. Okay? All right. Which of these are going to show up on tests sooner or later? 2 or 3 of them on the first test, a few of them on the third test. What's that equal to? 5 plus 4 is 9, and 9 plus 3 is 12. What's this equal to? 4 plus 3 is 7, and 7 plus 5 is what? 12, yeah. Notice this is associative property. You see it? 5, 4, 3, 5, 4, 3. They just grouped it differently. 10 minus 5 equals 5, and 5 minus 3 is 2. Minus 3 is 2, and 10 minus 2 is 8. 2 and 10 minus 2 is 8. So now you can see subtraction is the associative property didn't work for subtraction. It looks like the associative property isn't true anymore. 6 times 2 is 12, and 12 times 5 is 60. Very good. 2 times 5 is 10, and 6 times 10 is 60. So multiplication works for associative. 12 divided by 6 is 2. 2 divided by 2 is, no, not 0. 2 divided by 2 is 1. 2 divided by 2 is 1. 6 divided by 2 is 3. 6 divided by 2 is 3. And 12 divided by 3 is 4. But those are not the equal, the same, so it doesn't work for division. They're just illustrating that the associative property works for addition, not for subtraction. Associative property works for multiplication, not for division. And then here's a sequence. They want you to find the next 3 terms. Can you figure out? It goes from 4 to 9, 9 to 16, 16 to 25, 25 to 36. Do you know how to go about thinking a problem like that through? You know what to do first? What would you do first? Okay, what? Okay, you could count. Sometimes it helps to subtract these numbers and see what you get. Like 4 minus 1 is 3, right? And 9 minus 4 is 5. And 16 minus 9 is 7. And 25 minus 16 is 9. Are you seeing a pattern? 36 minus 25 is 11. 49 minus 36 is 13. So what do you think the next number? What are we going to have to add to 49 to get the next number? Okay. Look, we added 3 to the 1 to get 4. We added 5 to the 4 to get 9. 7 to, look at the pattern. 3, 5, 7, 9, 11, 13. What do you think I'm going to have to add to 49? 15. You see it? These are going up by 2. What I'm adding to the 1 to get this is 3. Then I have to add 2 more to that 3 to get 5. Go up to 9. 2 more to the 5 to get 7. Go up to the 16. These can be a little tricky. Yeah, they're kind of nasty. I think it may be the hardest thing we've done so far is figuring out these series sequences. But I would really encourage you to, first of all, just subtract these numbers. And then you can look at what you get when you subtract them. And you'll finally see a pattern. 3, 5, 7, 9, 11, 15. We're going to add 15. See, they're going up by 2. 15 and 49, add up 2. 64, is that right? Then you have to add a 17 to the 64. 81. Then add a 19 to the 81. Takes you up to 100. Tricky. There's another pattern here that you might or might not notice. Does anybody see another pattern? Okay, they're odds. Yeah, that's true. I'm thinking of another pattern that you wouldn't even have to subtract if you noticed it. But you might not think about this. Yes. It may be math that you haven't had much of yet. Okay. Okay. That's not what I'm thinking of. That would help. That would help. Do you know what squares are? Perfect squares? What's a square of 2? 2 squared. Do you know what that is? Have you had this before? You know what 2 squared is? 2 squared means 2 times 2. To square something is to multiply by itself. Have you had that before? Okay, that may be new to you. Well, I'm getting ahead of myself. But 3 squared, have you ever seen anything like that before? That means 3 times 3, which is 9. 2 squared is 4. 3 squared is 9. You know what 4 squared is? 4 times 4, 16. 4 times 4 is 16. You know what 5 squared is? 25. 5 times 5 is 25. 6 squared? 36. 7 squared? 49. 8 squared? 64. 9 squared? 81. 10 squared? 100. So if you happen to recognize your squares, you could get that one that way. So interesting. All right. I'm going to stop for today. Now, guys, listen to me very carefully. Some of you may be starting to panic a little bit. You're saying, oh, my goodness, we covered so much math. Don't panic. Don't panic. Relax. For one thing, you can watch the video, but I'm going to answer any questions you have. You know, you got the assignment sheet. You know what you need to work on. And you're going to be okay. You're going to be okay. Just take a deep breath. Just be determined to do your very best. Take me seriously. I'm not saying don't work hard, but just learn to relax a little bit and say, this is going to be fine. If I don't get it now, I'm going to get it. I'll get it. Just be patient with yourself, okay? Make sense? Anybody have a question or anything before I let you go? I want to pray again before I let you go. Anything at all? Okay, let's pray. Father, thank you for these kids. Thank you for their sweet spirit and their good attitude. Thank you, Lord, that I believe that they're really give it their best effort, and I pray you bless them. Help them, the ones that seem a little bit confused about some of these things, help them to latch onto this quickly and learn what they need to learn so we can just keep going and get as much math learned as we can this year. So bless them, encourage them, help them know how much you love them, help them know you're going to help them to know I'm going to help them, and there are probably other people that can help them, and they can help each other figure these things out. So just encourage them and help them to be patient with themselves and to just be confident that in time they're going to get this put together. So please encourage them and bless them. Give them a good day in the rest of their classes too. I pray in Jesus' name. Amen.